Section 9.2 is on solving quadratic equations by graphing. In the last section, we looked at and graphed a quadratic function, and recall that that's in the form y equals ax squared plus bx plus c. In this section, we're going to solve a quadratic equation that's very similar to that. It's going to be in the form ax squared plus bx plus c equals 0. Okay? And we're going to solve it by graphing. So the solutions of this quadratic equation, where it equals 0, are the x values when y equals 0. What is x when y equals 0? And those are going to be the solutions. So to solve this equation by graphing, we're going to graph it and find where it crosses the y-axis. Because at those points on the y-axis, that's where the equation y equals 0. So let's take a look at a couple examples here. So the directions say solve each equation, quadratic equation, by graphing. Notice this is different. It doesn't start with the y equals, it says equals 0. But what I need to do is graph y equals all of this. And the nice thing is I don't have to do all of the steps that I did in the last lesson. Basically, I need to find the vertex, I need to make a table of values, and then graph it. So remember that to find the vertex, we're going to start with x equals negative b over 2a. That's the axis of symmetry, but it's also the x of the vertex. So a negative 4 over 2 times 1 gives me positive 4 over 2, or 2. So that's the x of my vertex. So for my vertex, I now know what x is. To find y, I'm going to plug that in and see what I get. So my y is going to equal 2 squared minus 4 times 2 plus 3, or 4 minus 8 plus 3, or negative 1. So my vertex is the point 2, negative 1. Let's make a table of values. So I'll put x squared minus 4x plus 3 in the middle of the table here. Okay. And remember that I want my vertex to be the center point in my table, and I'll pick 2 values of x that are smaller and 2 values of x that are larger, and plug those in and see what I get. When I plug in 0, that's actually pretty easy. I get that y equals 3. When I plug in 1 squared is 1, minus 4 plus 3, that gives me a 0. When I plug in 3, I get 9 minus 12 plus 3, and that gives me a 0. And when I plug in 4 squared is 16, minus 4 times 4 is 16, plus 3, that gives me a 3. So there's the values of my table. So let's go ahead and graph those points. So I have 0, 3, 0, 3, there we go. Okay, 1, 0, 2, negative 1, 3, 0, and 4, 3. So there's my graph. Okay, that's the graph of the quadratic function, but the solutions of the quadratic equation are these 2 points right here where it crosses the x-axis. So this crosses the x-axis at x equals 1 and x equals 3. Those are the solutions to the quadratic equation x squared minus 4x plus 3x equals 0. So notice that when x is, let's look at our table here, when x is 1, when x is 1, my y is 0. When x is 3, my y is 0. And that's really what I'm looking for, because this equals 0. So in other words, what are the x values when y equals 0? 1 and 3, and those are indeed my solutions, which is where the graph crosses the x-axis. Let's take a look at another example. Here I have x squared plus 8x plus 16 equals 0. So let's go ahead and find the vertex. So x equals negative b over 2 times a, or x equals negative 4. So that's going to be the x of my vertex. Now to find the y, let's plug that in. So y equals negative 4 squared plus 8 times negative 4 plus 16, or 16 minus 32 plus 16, and that gives me a 0. So my vertex is the point 4, negative 4 is 0. Let's make our table. And remember, I'm going to plug in the vertex as my center point, and that was negative 4, 0. Let's choose two x values that are smaller than negative 4, so that would be negative 5 and negative 6, and two that are larger, negative 3 and negative 2, and let's plug those in. So negative 6 squared is 36, negative 6 times 8 is negative 48, plus 16, and that gives me a 4. Negative 5 squared is 25, minus 40, plus 16, and that gives me a 1. Negative 3 squared is 9, minus 24, plus 16, gives me a 1, and negative 2 squared is 4, minus 16, plus 16, and that gives me a 4. And notice my table looks right because I have the symmetry in my y values. Let's go ahead and graph those points. So I have negative 6, positive 4, negative 5, 1, negative 4, 0, negative 3, 1, and negative 2, 4. And remember, what I'm looking for in this graph is where does it cross the x-axis? Well, technically this one doesn't cross the x-axis, but the only place it touches the x-axis is right here at this point. And that's where x is equal to negative 4. So this quadratic equation has just one solution, x equals negative 4. And I can confirm that by looking back at my table, because when y was 0, my x was negative 4. So that's my one solution. So a quadratic equation can have two solutions, or it can have one solution. Let's take a look at another example here. So negative x squared minus 2x minus 3 equals 0. Let's find the x of our vertex. That's negative b over 2 times a, or 2 over negative 2, or negative 1. So my vertex has an x-coordinate of negative 1. Let's plug that in to find the y-coordinate of the vertex. So negative 1 squared. Now this gets a little tricky. We'll take a look at that in a minute. Negative 2 times negative 1, and then minus 3. So I want to square my negative 1 first, which gives me a positive 1, and then multiply it by 1. So that's negative 1 plus 2 minus 3. That gives me a negative 2. So my vertex is the point negative 1, negative 2. Let's make our table. Negative x squared minus 2x minus 3. And I'm going to put that, my vertex, in the middle of my table. Choose two x values smaller. Choose two x values larger. I'm liking that 0. That's going to be nice. And let's plug this in. So negative 3 squared is 9, and then multiply it by the negative 1. Plus 6 minus 3 gives me a y value of negative 6. Plugging in negative 2. Square it first, that gives me a positive 4, times negative 1 gives me a negative 4, plus 4 minus 3 gives me a negative 3. Plugging in 0, this becomes a 0, that becomes a 0, so I just have a negative 3. And then plugging in 1 squared is 1, times negative 1 gives me a negative 1, minus 2, minus 3 gives me a negative 6. Let's graph those points. So I have negative 3, negative 6, negative 2, negative 3, negative 1, negative 2, 0, negative 3, and 1, negative 6. So remember, again, we're looking for where this crosses the x-axis. And this one actually doesn't. This one will never cross the x-axis because notice the parabola is going down. It's not heading towards the x-axis. So for this one, there is actually no solution. This graph will never cross the x-axis. There is no value of x that makes our original equation up here true. And our last example, x squared minus 4x plus 2 equals 0. As we've done with all of the others, let's find the x of the vertex. Negative b over 2a, or 4 over 2, which gives me an x coordinate of 2 for my vertex. Let's find our y. So 2 squared minus 4 times 2 plus 2 gives me 4 minus 8 plus 2 gives me a negative 2. So my vertex is the point 2, negative 2. Let's make a table. Put our vertex in the center of that. So 2, negative 2. 2x values smaller. 2x values larger. I like the 0 because x squared becomes a 0. Negative 4x becomes a 0, so that gives me a y of 2. Plugging in 1 minus 4 plus 2 gives me a negative 1. Plugging in 3, I have 9 minus 12 plus 2 gives me a negative 1, and plugging in 4 gives me 16 minus 16 plus 2, or 2. Okay, so let's graph those points and see what it looks like. So 0, 2, 0, 2, there we go. 1, negative 1, 2, negative 2, 3, negative 1, and 4, 2. Okay, so there's my parabola. And remember what I'm looking for, I'm going to redraw this side a little bit better here. What I'm looking for is where this crosses the x-axis. So it seems to cross right here and right here. But notice, those aren't exact points. They actually cross, this one on the left is between x equals 0 and x equals 1. And the one on the right is between x equals 3 and x equals 4. So you could write your answer like that. I think that's probably the way the textbook does it. I kind of like to do it like this. This says that x is some value that is greater than 0 and less than 1. And the same thing with 3 and 4. X is a value that's greater than 3 and less than 4. And notice this actually kind of makes sense if we look at our table. In previous examples, we were looking for what is x when y equals 0. Well, notice right in here, there would be a 0 in the y's because it goes from 2 to negative 1. It goes from being a positive number to being a negative number, so it must have jumped over 0. And the same thing right here. Going from negative 1 to a positive 2, it went through 0 in there. Which makes sense because didn't we see from the graph that our solutions are going to be somewhere between 0 and 1 and somewhere between 3 and 4. So to sum up this lesson, to solve a quadratic equation by graphing, you're going to graph the quadratic function, see where it crosses the x-axis. It can cross it in 2 distinct points, like 3 and 4. It can just hit the x-axis in 1 point. It's possible that it may never cross the x-axis, or it can cross the x-axis between 2 integral values.